Aircraft functionality. Content, aircraft RNAV system and database. Not all RNAV systems have a database. Navigation specifications will identify if the computer is required to have a database. Database capacities, where appropriate, vary according to the particular RNAV system. Where an RNAV system has a database, waypoints and path terminators required by that particular aircraft operator are stored within the capacity limits of the database, as well as coordinates for all ground-based nav aids. A comprehensive process is followed to upload this data to the database. Each state is required by ICAO to publish ATS routes, nav aids, aerodromes and related procedures in the AIP. A data house produces a global data set using the state's AIP as a primary source of information. Data houses are employed by the aircraft operator to collate specific information from each state to support their client's required operations. The data houses pass this collated information, in ARINC 424 format, onto the original equipment manufacturers, referred to as data packers, to be coded and then uploaded into the appropriate target RNAV system. The databases are updated and validated in accordance with the ICAO AIRAC cycle. Aircraft functionality. Continue. Aircraft RNAV system and database. Continue. There are several manufacturers of RNAV systems and the formats used by these systems are different. In addition, no two aircraft operators will require exactly the same information. Some aircraft operators will create company routes, a predefined series of waypoints, to enable quicker uploads of specific routes. If the data is incorrect in the database, the pilot may be unaware. Good airmanship should ensure that the flight path extracted from the database is checked for accuracy and consistency against the chart information. Using the data, for nav systems with a database, the pilot will select the company route or waypoints in turn from the database to create a route. The pilot is inhibited from changing any data in the database to avoid risk of data corruption. For RNAV systems without a database, the pilot is required to manually insert the waypoints. This functionality will limit the navigation specifications these aircraft can meet.
In this video, the aircraft is cleared on the Snake 1 Alpha arrival. We can see on the display the waypoints for this arrival, Snake, Chirp, Finch, and so on. Before getting to Snake, the controller re-clears the aircraft on the Snake 1 Bravo arrival, so the pilot needs to change the arrival star. To do this, the pilot selects the arrivals key and then goes to the index and selects Arrivals, which will bring up a list of stars that is held in the navigation database. The pilot then pages down until the Snake 1 Bravo is displayed on the screen and selects this star. To load the star and activate the flight plan, the pilot selects the Execute key. Now, by using the leg key, the pilot can call up and confirm the waypoints for the Snake 1 Bravo arrival. When the navigation computer has a database, it is a straightforward set of inputs to change the star, and because the waypoints are then loaded automatically, there is less likelihood of an error occurring due to manual manipulation. In this example, the air traffic controller has cleared the aircraft to fly the Snake 1 Bravo arrival. In older generation computers, there may not be a database. Therefore, to be able to fly this arrival, the pilot would have to manually create a series of waypoints as listed in the chart above the video. The waypoint list that is shown on the navigation computer display is the current set of coordinates that the aircraft will navigate to. The list is in order, meaning that the aircraft will fly to the waypoint that is at the top of the list, and then, once it has passed over that point, the computer will step to the next active waypoint in the list and provide guidance to that point. This list is referred to as the active flight plan. You can see that the coordinates for Snake are currently listed as the last waypoint on the active flight plan list. Once the aircraft has flown over the first waypoint on the list, that waypoint drops off the display, creating an empty slot for another waypoint to be added at the bottom of the active flight plan. As the aircraft has been cleared for the Snake 1 Bravo Star, the next waypoint will be Cobra. As this navigation computer does not have a database, the pilot must now manually insert the Cobra coordinates. What you are seeing right now is that manual insertion. Once the new waypoint has been accepted, it appears as the last waypoint in the active flight plan. Clearly, inputting coordinates is a laborious and time-consuming task, and is also very prone to error. This is why manual insertion of waypoints in terminal airspace is not operationally allowed. Finally, it should be noted that RNAV 5, the mandated en route navigation application, does not require the aircraft's computer to be fitted with a navigation database.
Aircraft functionality. Continue. Creating the path. The airspace planner and the procedure designer design the standard instrument departures, standard terminal arrival routes and ATS routes with a sequence of waypoints. This is known as the desired path. These waypoints are loaded into the aircraft's RNAV system. The computer links the waypoint together in order and creates a flight path. This path is known as the defined path. There can be some small computational errors called path definition errors. Aircraft functionality. Continue. Flying the path. The aircraft uses one or more sensors to estimate its position, and the RNAV system calculates the deviation from the defined path and adjusts accordingly to maintain that path. How well the actual and desired paths coincide, and especially the ability to follow fixed path turns, depends on the coding of the database, the navigation sensors, the capabilities and functionalities of the RNAV system, and/or how the aircraft is flown, manually following a course deviation indicator, manually with the aid of a flight director, or by autopilot. Aircraft functionality. Continue. Implications for PBN. PBN operations require lateral accuracy, integrity and continuity of aircraft systems together with particular RNAV system computer functionalities to meet specific requirements. These requirements are defined for a particular navigation application in the associated navigation specification. Positioning accuracy. The lateral track accuracy is defined by the path that has been defined by the RNAV system, the navigation sensor used to estimate the position, and the ability of the pilot and/or the system to fly the defined path. If the pilot or system is unable to maintain the defined path, this is known as the flight technical error. The performance limits for the flight technical error are laid down by ICAO for each navigation specification. The aircraft will be certified demonstrating the ability to fly at the required navigation specifications. Specified lateral accuracy 95% of the flight time with all errors combined, TSE. Aircraft functionality. Continue. Implications for PBN. Continue. Continuity. To meet a specific navigation application, both the signals in space and the aircraft systems must meet the required accuracy, integrity and continuity for that operation. PBN requires that an aircraft and its systems should be able to perform for the whole of the defined operation, as long as it was operating correctly at the start of that operation. The probability of failure and therefore being unable to complete an operation must be acceptably low. Some navigation specifications in the oceanic/remote continental phase of flight will require a higher continuity for these operations. High continuity is the carriage of a second, independent RNAV system and sensor to provide redundancy. Aircraft functionality continue. Implications for PBN continue. On-board performance monitoring and alerting. Aircraft RNAV systems do not necessarily provide the pilot with a warning when the required lateral accuracy limits have been exceeded. However, some RNAV systems do have extra functionality to monitor the navigation sensor error and issue alerts. Those RNAV systems with this extra functionality, on-board monitoring and alerting, are RNP capable and are called RNP systems. Some navigation applications will require RNP capable systems for their operations.